So what's next for AI? What is the next wave of humanoids, robotics, and other form factors? While Tesla seems to be well ahead in its Vision AI technology and its Optimus humanoid bot, Nvidia is powering many of the other robot companies. Jensen Huang, CEO of Nvidia, just did a keynote speech at Computex 2024 in Taiwan, and he said some very, very important statements. He said the next wave for AI is physical AI, and he said that one day, everything that moves will be autonomous. Today, we have a robotics expert with us who will explain the entire ecosystem that NVIDIA is providing to its 9 humanoid vendor partners, but also the countless human-scale companies. We're in the beginnings of an explosion of robotics, and it's now here. Thank you so much, Scott. I appreciate you joining me.
Oh, Herbert, it's a pleasure to be joining you again here from Starbase. I don't know if you can see, there it is. Still can see the ship behind us. So I'm going to try to get myself in the shade because if you may have noticed, I did put on enough sunscreen today.
Well, thank you for, you're always on the move and you're always at the leading edge. In this case, you're here at Starship ready to watch its launch tomorrow. But the other big tectonic thing that happened, of course, was NVIDIA and their announcements, and they're being very, very pretty aggressive about what they want to do. So we're going to watch 2 clips. The first one is this pre-recorded video that they played at the conference. Let's watch this.
The era of robotics has arrived. One day, everything that moves
will be autonomous. And he went through all the tools and he called it a stack, robotic stack, and they're going to partner with any company that wants to make their physical object become autonomous. What did you learn from that video there?
Yeah, so what he said is that anything that moves will be autonomous. And that's a rather bold statement, but I think he's making that statement because they see that that's what it's going to be. It doesn't mean it's going to be tomorrow or the day after, but clearly looking in the future, anything that moves, the simplest thing, is going to be autonomous in some way. And that includes, everything from your vacuum cleaners on up to humanoid bots and anything else that you could imagine. And the question is how you do that. And so they've got a very big, bold vision on how to do it, and that is to do simulation for the training. For the reinforcement learning, you need good training, and you need, you need a really good simulated world. Simulation is very key to being able to do that. But the thing about simulation is it also has its shortcomings. It's imperfect. It's not quite like the real world. So you still need to do a lot of training in the real world. But what you want to do is try to narrow that gap as so much. So they're talking about sim to real, and they're going to be learning more and more about how to improve the physics, because it takes first a good physics model. And a lot of the physics that we learn are approximations of the real world. It's not exactly how it works, but it's a pretty good guess, pretty good approximation that mechanical engineers like me could use to design bridges and buildings and all kinds of structures because it's good enough. But to get down to the fine detail of motion that you would need for a robot, you need better models than that. So you can create these better models. The thing is, it's really hard to calculate the answer with it. You used to be able to just do it with like the calculator and, so a few graphs here and there, and then you had to start using computers to do it. And then you model and you start running out of compute. So once you start getting the compute, you can do that a little bit better. But the other thing that looks like is probably going to happen is eventually a lot of these neural networks will be trained just themselves on how the world works. And they'll be able to model physics and do a very good job of simulating the physics that the normal AI needs to train. So that's kind of where I see a lot of it going, and that NVIDIA is working there with the whole idea of Omniverse, where Omniverse is going to be this huge digital world that any sort of assets can go in there and perform and be integrated together, so people can collaborate in the same space with whatever work they're trying to do with someone else. So it could be someone that's setting up an automation cell, someone else that's going in to train something, someone else that wants to figure out, well, how's the safety fencing supposed to go up around this thing? You could work on that collaboratively at the same time, and so the same space. And it would be nice to make sure that everything that's in there performs in that simulated world the way it would be in the physical world. And when you do that, then you can start to do a lot. You can start training all sorts of autonomous agents to do a lot and get to this zero shot kind of thing. You train it to do a complex task and then it goes ahead and does it. And we're seeing glimpses and glimmers of that already. We saw that was done by Unitree with their H1 bot that's able to do a backflip. Now, how did that thing learn to do the backflip? Well, they taught it in that robotic gym that Jensen was sort of talking about to be able to do something like that. And it practiced and practiced and practiced until it could figure out how to do it. And then when they went to the real world, it wasn't perfect, but it was close enough. And then their robot was able to overcome the imperfections and then figured out. I actually found out directly from the CEO of Unitree that yes, that was emergent behavior. That it learned to jump forward to recover from that tumble it was about to have when it could not do the backflip perfectly. So, and this is how it kind of, and a lot of that comes because they keep pushing the bot around. Remember, they're always pushing the bot. Because the bot's learning how to recover. It's learning how to stumble and recover.
Gotcha. Nice. Okay, so this is Nvidia, right? And they're pushing hard. They're partnered with so many companies now, both humanoid, and you can see here anything that moves is going to be autonomous. The difference, though, I think, is that Tesla is ahead in terms of their vision AI technology. They're ahead in terms of their humanoid bots. They've hinted that they're going to make lots of different kind of humanoid form factors, or robotic form factors as well. They call it bot animals. But they're also open to licensing this technology. But by the time Tesla opens it up and says, hey, if you want to partner with us, maybe it's too late, maybe it's not too late, but this is why you see Nvidia going full force on this. I'm going to go ahead and play the part where Jensen Huang was on stage and he talked about this, and then we'll talk about all these topics because this is very, very important at this point.
Be extraordinary. Let me talk about what's next. The next wave of AI is physical AI. AI that understands the laws of physics. They have to, of course, have excellent cognitive capabilities so they can understand us, understand what we asked, and perform the tasks. Of course, when I say robotics, there's a humanoid robotics that's usually the representation of that. But that's not at all true. Everything is going to be robotic. All of the factories will be robotic. The factories will orchestrate robots, and those robots will be building products that are robotic. Robots interacting with robots, building products that are robotic. Well, in order for us to do that, we need to make some breakthroughs. First, we're going to create platforms for each type of robotic systems. One for robotic factories and warehouses. One for robots that manipulate things. One for robots that move, and one for robots that are humanoid. And so each one of these robotics platform is like almost everything else we do. A computer, acceleration libraries, and pre-trained models. Computers, acceleration libraries, pre-trained models. And we test everything, we train everything, and integrate everything inside Omniverse, where Omniverse is where robots learn how to be robots. Now, of course, the ecosystem of robotic warehouses is really, really complex. It takes a lot of companies, a lot of tools, a lot of technology to build a modern warehouse. And warehouses are increasingly robotic. One of these days will be fully robotic. Now let's talk about factories. Factories has a completely different ecosystem. A robotic factory is designed with 3 computers. Train the AI on Nvidia AI. You have the robot running on the PLC systems for orchestrating the factories, and then you, of course, simulate everything inside Omniverse. Well, the robotic arm and the robotic AMRs are also the same way, 3 computer systems. And we provide the computer, the acceleration layers, and pre-trained AI models. We've connected NVIDIA Manipulator and NVIDIA Omniverse with Siemens, the world's leading industrial automation software and systems company. This is really a fantastic partnership, and they're working on factories all over the world. And that's the factory, the robots inside, and of course, all the products are going to be robotic. So there are 2 very high volume robotics products. One, of course, is the self-driving car, or cars that have a great deal of autonomous capability. NVIDIA, again, builds the entire stack. Next year, we're going to go to production with the Mercedes fleet, and after that, in 2026, the JLR fleet. The next high-volume robotics product that's going to be manufactured by robotic factories with robots inside will likely be humanoid robots. And this has great progress in recent years, in both the cognitive capability because of foundation models and also the world understanding capability that we're in the process of developing. I'm really excited about this area because obviously the easiest robot to adapt into the world are humanoid robots because we built the world for us. We also have the most amount of data to train these robots than other types of robots because we have the same physique. And so the amount of training data we can provide through demonstration capabilities and video capabilities is going to be really great. And so we're going to see a lot of progress in this area. Well, I think we have some robots that we'd like to welcome. Here we go. About my size. And we have some friends to join us. So the future of robotics is here. The next wave of AI, and of course, you know, Taiwan builds computers with keyboards. You build computers for your pocket. You build computers for data centers in the cloud. In the future, you're going to build computers that walk. And as it turns out, the technology is very similar to the technology of building all of the other computers that you already built today. So this is going to be a really extraordinary journey for us. Thank you all for coming. Have a great Computex.
Wow. Okay. He said a lot there, Scott. What did you pick out from there?
Okay, so the first thing Jensen sort of talks about is the fact that you will have robots talking to robots within the factory, pretty much self-organizing themselves. And a lot of that is, let's say, already been anticipated back in when they were starting to talk about this Industry 4.0, about factories being, easily configurable to be able to do different things in different products, which is more like a concept of some ideas that you would need a lot of censoring and the ability to sort of oversee what was going on there, but nobody really knew how to do it. Now there's kind of a better idea how to do it, that these humanoid bots and a lot of AI is going to make this possible. It's sort of what Elon has referred to as, the alien dreadnought, to be able to produce everything. They'll be able to reconfigure. So the idea of factories being able to reconfigure themselves has been around for a while as sort of a goal. And now people are starting to call it more of like an Industry 5.0. Now, the whole idea of this is like we had the first industrial revolution, then the second, and then, and the third, in various stages that historians are able to go back in time and say, oh, it happened on this date. But as it happens, we're not quite sure. So in the early 2000s, there was discussion that we're kind of moving into this fourth industrial revolution that would be talking about these smart factories. And that was where these Internet of Things and all that came from. So I'm kind of surprised that we've already evidently are leaving the fourth industrial and maybe going into the fifth industrial revolution. And what's the difference between the two? I haven't quite figured that out, except that shows an acceleration, and that everything will be able to configure, will be able to talk to themselves. And that all you'll have to do is explain to the bot or the AI what it is you want to do. Or demonstrate it. I mean, this is the other thing that's important, is people keep on thinking we have to tell the robots what to do. Well, in some cases we will be able to, because it sort of knows what that language is, because it's seen that it already comes pre-programmed. But if there's some particular task you want it to do that it's never seen before, you can either talk your way through it, or you can just go over and show it. I mean, that's just the easiest way, and that's how we teach a lot of other people. We don't tell them how to use a nail and hammer. I mean, we can describe it. You go over here, you pick up a nail, you put the pointy head down, you kind of place it over the piece of wood where you want it to be. Make sure your thumb is not on the head of the nail. Then you take your hammer and you hold it at the very end and you swing it. And it's like, come on. It's like you want to show your kids how to put a nail in a piece of wood. You go and demonstrate it, and you can talk about what you're doing when you're showing it, so they understand the language. They understand what the pointy end of the nail is, what the head of the nail is, what the end of the hammer is, all that stuff. If you've never seen those things before, that language is not going to help you. And the old tricks our dads would show us are like, well, sometimes you want to put a pilot hole in there to make sure it goes down the right way. It's like, so these are the things that you'd want to demonstrate, and then eventually you can attach language to that. And that just means powerful AIs will make it possible. And then there's no reason why computers can't start talking to other computers. We've already seen these AIs talking to each other. I mean, there's examples on X of people having fun with the different vocal versions of ChatGPT getting into discussion on whether one or the other was an AI. So it's like, we know we can do something like that already. And it's just a question of being able to implement it in, let's say, a very productive kind of way.
Wonderful. Thank you, Scott. So tell me about what I said earlier about Tesla. And does Tesla have all of the ecosystem that Nvidia just showed that they have, that they're offering to any partner? And he said, you can take all of it or whatever part of the stack that you want. And B, do you think Tesla will license this to these guys as well?
They could. I mean, the question is whether Tesla is going to kind of go fully into everything in the automation. Now, there are hints that they're working on mobile robots, these AMRs. So what you saw on the stage with Jensen is an example of an AMR. And the AMRs can do lots of things. I mean, for the most part, they're working just in a factory to move goods around and do something like that. But we're seeing them also outside of factories of being like pizza delivery and stuff like that. It's the same idea. It's a small autonomous vehicle that's able to move around to deliver something wherever it's needed. So, it looks like Tesla is considering something like that because they may be thinking of how is Optimus going to integrate with everything else in the factory, because they're well aware of what it's like to try to run the entire factory. So are they going to create a similar kind of backbone, which is, let's say, similar to what Nvidia is looking at? Because Nvidia is like, well, all these systems and subsystems have to talk to each other in one way. And the question is, who has the most experience to be able to do it? Nvidia is more than likely learning from their customers. But Tesla already has learned those lessons, already knows what it needs, already knows what it wants. The question is it going to be a full enough stack for everyone outside of this kind of Tesla ecosystem? And there's no reason why they may not consider, say, hey, this could be very profitable kind of business to either spin off or to build on top of. So I would say they have all the pieces.
Yeah, Elon's already obviously pushing hard to license autonomy, right? FSD. These are mobile robots. They have wheels.
And he's talking about,
you can make a small, tiny car that's the size of a foot, 2 feet, 12 feet, 5 feet, whatever you want. And it's the same
I'm
thing.
sitting in a mobile robot right now. It's not the kind of mobile robot that people usually associate with what you see in a factory, but it's got all the same elements and components that you would need for a mobile robot. No doubt about it. It's got wheels. It's got motors. It has the ability to navigate autonomously.
Yeah, I'm predicting
Batteries.
that Elon and Tesla will announce that they will license this, and that they will do more than just the humanoid robot. That they will come
if
out
they're
with
thinking
a whole
of
family.
selling, because remember they talked about maybe next year selling Tesla Bot to other customers, and that means they're going to need to integrate into their ecosystems, whatever they have within it. So a factory is very complex in that there's all these commands and orders coming on down on what needs to be done, and making sure these things are integrated into the the MES system and any other systems that are organizing what's going on, the PLCs, safety equipment, all that. And so, a lot of things are set up there for the humans to be able to read that will have commands. Okay, this is the task you need to do, this or that, or they may notice that a gate is down and they're have to wait for it to come up, or there's a red light versus a green light telling the human what to do or not to do. Well, those are things that the bots will either read or the bots will pick up directly through a command, because they don't necessarily have to see that there's a red light there. They just have to be told that at this location the light's red, and then they'll know, oh, okay, then I'm not supposed to enter or do something like that. Or if there's some instruction of what they need to pick up, or if they're picking up packaging, that there may be some priority of which package to pick up first. So you may see a bunch of them. It's like, oh, this one's more important. Get that over to the cart before this, and then you can take care of those. And a lot of times the human may know that. They may do it first come, first serve, and not realize that there's something that's going to be hot shotted to some other part of the factory.
One of the things you've been saying for quite a while, though, is that there's a role for all these different form factors. So there's a role for the industrial robot. That's obviously taken off. Lots of factories have that. But there's also a role for little tiny arms, right? Little tiny human scale robots. And then there's a role for the wheels, the bots with wheels. Then there's a role for a humanoid with a walking. So why would Elon and Tesla just say, we're only going to do just a car and we're just going to do just a humanoid? They're going to do all of it.
Yes.
Right. Speak a little bit about that there's a role for all of these kinds. Like anything that is physical will become autonomous. Anything with a camera can become intelligent and become autonomous.
Yes, absolutely. So yeah, all you need is a camera. All you need is some inference chip to understand what the camera is seeing and how it relates to that particular embodiment you have, and then you're kind of good to go. Obviously, there's a lot of training and other things that go in there, but it's within a couple of years, we're going to have these consumer products which are just going to do all kinds of crazy things that we would never imagine. Just be able to move around and do whatever if we need. Because today I already saw one. One of your fans was coming down the road with what looked like a Segway, and it is a kind of a Segway that has a camera on it, and it ferries him around here and there, and then he could just step off it, and it just sits there waiting for him. and it's looking around, so it can almost be like a little security cam, and it's understanding its
What?
environment.
Really?
Yes. So it was basically, it's a Segway, but it's an upscaled Segway that has more intelligence and that it sees where it's going. So yeah, you could step on it and lean forward like you would in the Segway, but at the same time, it'll help sort of decide what's the best path to navigate if it sees something that might be in the
Yeah.
way. So it's rather interesting. These technologies are getting smarter and smarter. Eventually, a Roomba will be smart enough that you might actually call it a real robotic. Well, you might even call it a vacuum cleaner, but also a robot because it has the intelligence you would expect.
You can talk to it. Yeah, you
Yeah.
can talk to it, and
Mhm.
it'll talk back to you.
Yeah, absolutely.
And you could say things that just by voice command it'll understand, right? It'll say like, there's a chair on that rug, move the chair out first, and then vacuum the rug, and then put the chair back in. And I'll do what you tell it to do, I guess. It'll know
Exactly.
these things. It's not that hard.
Yes, exactly. Because the problem is I have to clean up and move all the furniture around for it, and I'd rather have it do it instead. I mean, that's what you have to do to vacuum properly.
Yeah. What else did you hear today from the NVIDIA conference when he was out there talking that struck you a little bit, something new, maybe something pretty bold?
I think just overall, him saying that everything that moves will be autonomous. That that's this big picture they have, and it seems like a pretty bold statement. But they've made bold statements in the past, and they've lived up to it. There's no doubt about it. So they kind of have a crystal ball here of really understanding where the industry is going, what's going to be needed, and that there's a huge opportunity for these kind of embodiments. And probably the only company that would be close to competing in the space is going to end up being Tesla, because they're working also the embodiment. They're working on similar kind of compute capabilities. Otherwise, it's basically almost like OpenAI for the LLM part, and then Nvidia for the embodiment and everything else. And competition is healthy. So not just for Tesla, but remember, do you want Nvidia to necessarily also dominate the world in OpenAI? So it's good to realize that there's going to be some of these other ecosystems and other players that will be out there that will be appropriate.
How big do you think the market is? So you and I have done many, many videos on humanoids. We've talked about how the humanoid market is $44 trillion. It's like 50% of the GDP, the global GDP. It's labor. What about these other form factors, these little hands, these little robots, anything but a video camera? Is that equal, do you think? Or is it even bigger maybe? Or is it much smaller than the humanoid form factor?
It could in the end be similar, because you're talking about labor, and it's more or less getting things done. And the human form factor is good for doing a lot of things, but it's not a specialist. And sometimes having things that are more specialized are a little bit better for certain tasks. So, I mean, the idea of, okay, do you want to have a humanoid bot pushing your Dyson around and having the same problems we humans have? That's like, oh, it's really hard to get underneath the bed and do all these other things. Or do you want to have like a more embodied kind of thing? When it comes to, oh, I need to look behind the wall for something. Do we want Optimus to go out and get one of those scopes that you go in and kind of go around to fish to look around something? Or you just want like some little autonomous spider that you send in the back of the wall to go around and look for whatever it is that you're trying to inspect? So you can imagine there's all these things that, as humans, we've had to develop these tools to allow us to do it. But if you make these things a bit more autonomous, that could be a game changer for absolutely a lot of things. And we have an interview coming out with Agility where let's say they made a good case about, we don't think a human hand is necessarily the best idea for the end of it, because traditionally the industrial robot has been what they call a manipulator. The idea of it is to move things through space. And that the thing you move through space is the thing we call an end effector or end of arm tooling. Those are these words that they use in the robotics business to like cut the amateurs from the people who know what's going on. But basically, that's the language we try to use. But in the end, it's like, it's a tool. It's something you grab. And the thing is, industrial robots don't grab end of arm tooling. The end of arm tooling is actually mated onto it. It's snapped on. It's like a permanent part of it. So rather than grabbing a drill, the drill is actually attached to it. And when it's done that way, the bot can use it, let's say, more efficiently than you can with the human hand. So the human hand is very good at being a specialist of picking up any kinds of tools. But there may be situations that, no, you want a tool for that job, and you don't want to have this funny hand in the middle. Now, that's their argument, okay? I'm not saying whether they're right or wrong, but I do like hearing the contrarian points of view on all these things, and Peggy and Melanie make a pretty strong case about that in that understanding. So the reason we're looking at the humanoid form factor right now is because all the work that has to be done has been designed around the human form factor, the tooling and everything else. I don't want to have to buy new tooling. I already have existing tooling. How do I reuse that? Oh, we'll have a humanoid bot with a human hand that can pick it up and continue to use it. But eventually you're going to start saying, well, I've got to replace that tooling anyway. Why not come up with a tooling that's specially designed for a robot?
Mm-hmm.
So in the end, it's gonna sort of follow that route, because you don't necessarily need a 5-finger hand. You are able to do it with 2 fingers. In some cases, no finger hands. Vacuum grippers are very good at picking up boxes and moving them around. They don't have any fingers.
So just reflecting back, you've been in the robotics industry for a long time. You obviously, at the time, the industrial robots pick and place, but very, very precise. Not that smart. No autonomy necessarily. It's all programmed. And then people started playing around with the autonomous humanoid bot, right? The Boston Dynamics and the Honda Asimo and these other bots, but they were very fully programmed. Then we hit this moment when Tesla goes, we're going to build this humanoid bot, and everybody just got blown. They laughed. They laughed at the bot. They thought, okay, good luck. And then perfect timing. And then all of a sudden, Nvidia comes out. They show OpenAI comes out. They show that AI is actually fairly intelligent. Now, when you see Nvidia, Jensen Huang come out there and he actually does say, this is, how powerful it is, right? I mean, I'm just saying that it's powerful when you see somebody else like Jensen Huang say things.
Absolutely.
Any last comments? Yeah.
No, I think that's pretty good. I'm like at 5% battery, so I'm going to drop any moment here.
Okay. Well, thank you so much, Scott. Appreciate you. This was great.
You're
thank
welcome.
You for giving us your feedback.
I'm going to go out, and it's like 108 degrees here, believe it or not. Yeah. So I was trying to get in some place cool. So one last shot of her, because the next time I come out here, it might not be there.
It's going to be up and landing. Thank you so much, Scott. Appreciate you. See you guys.
Okay.
Bye-bye.
Yeah. Thank you, Herbert. Bye.
I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.